Sheet metal parts are made by bending and deforming flat sheets of metal. In SOLIDWORKS, sheet metal parts can be folded and unfolded, enabling you to show them in the flat pattern as well as their bent-up state as you see here. There are two ways in SOLIDWORKS to design sheet metal parts. You can either start the part as sheet metal from scratch, using sheet metal features through the design process, or you can design it as a regular solid part and later convert it to a sheet metal part. Most users design sheet metal parts as sheet metal from the beginning. We'll take a look at this approach first, starting with the basic sheet metal feature, the base flange. Before I get started creating a sheet metal part, I want to take a moment to point out some of the sheet metal features that are available once the first sheet metal feature has been added. On the left in the feature tree, you can see a list of features I used to create this part. These are no different than any other feature. I can click on the base flange feature, for example, and select the Edit Feature icon to access all of its settings, or edit the sketch used to create the feature. There are two new features listed here that are specific to sheet metal parts, however. The first is the sheet metal icon located in the sheet metal folder. This is where sheet metal specific parameters like the default bend radius and relief type are stored. These settings apply to this entire sheet metal body. If you're working with a multi-body sheet metal part, you will have a separate sheet metal feature for each body, but we'll talk more about that later. If you want to edit any of the default settings, you can click on this feature and choose Edit Feature. Once you do this, you can see all of the general default options for the sheet metal part. This first area is where the bend parameters are stored. The fixed face is defined in the flat pattern feature, so you can see that right now it's blank here. You can choose to override the default bend parameters and enter a custom thickness and bend radius, or you can choose to use the defaults, and these options become grayed out. The next two sections of the sheet metal feature properties are the default bend allowance and auto relief for this part. At this point, it is only important to note that this is where you would change these defaults. We'll look at various options for each of these parameters later. In addition to the sheet metal feature, a new flat pattern feature has also been added. Think of this as the information holder for all of the bends used in a sheet metal part. If you expand the feature, you'll see a list of each bend as well as a sketch. We'll take a look at the sketch in a moment. Notice the flat pattern feature is suppressed. If you right-click and unsuppress it, you will see that it flattens the part. If you click on the feature and suppress it, the part folds back up. To make this process simple, SOLIDWORKS has added a flatten button on the sheet metal toolbar that will toggle the suppression state of this last feature. While the part is in the flattened state, you can see some lines become visible. These are the bend lines that are stored in the bend lines sketch. These can be useful for dimensioning purposes if you want to pass along a flat pattern drawing to your manufacturer. There is quite a bit more you can do with the flat pattern feature, but we'll save that for a future lesson. Before concluding this lesson, let me address a common mistake. If you want to create a cut that crosses a bend, do not use the flat pattern. In fact, it's a bad idea to add any features while the part is in its flattened state. Later, we'll take a look at the fold-unfold feature that allows you to add features such as cuts to your flat pattern. The base flange is the basic type of sheet metal feature. You can access it using the Insert Sheet Metal drop-down menu, or you can use the sheet metal toolbar. If you don't have the sheet metal toolbar active, you can right-click on the command manager from here. Just check the sheet metal option and the sheet metal toolbar is added. A base flange is a sketch-based feature just like the extrude and revolve commands. This means a sketch is necessary to define the geometry you wish to create. As with any sketch-based feature, you can create a sketch first, or you can launch the command and a sketch will be started automatically, like I've done here. I'll create the sketch on the front plane. I'll create a U-shaped sketch that is 4 inches by 2 inches. This will serve as the overall shape of the sheet metal part. Notice that I don't need to use sketch fillets on any of the corners. SOLIDWORKS will automatically convert sharp corners to round bends for me. SOLIDWORKS will also automatically create the thickness of the part, so a single open contour is all I need in this sketch. I'll exit the sketch, and the base flange command is launched. You see a preview of the feature, and the property manager shows all of the sheet metal options available. The first section is similar to the extrude command, where I can tell SOLIDWORKS the length, direction, and end condition of the extrusion. In this case, I'll define a 4-inch mid-plane extrusion. Now I can define the sheet metal parameters. This is where I tell SOLIDWORKS how thick a piece of sheet metal I will be using and what bend radius I want. I will set the thickness to 0.03 and the bend radius to 0.1. Notice the reverse direction checkbox under the thickness area. This will tell SOLIDWORKS to set the thickness the outside or inside of the sketch. By the way, the bend radius you specify is always the interior radius, whether you add material to the inside or outside. The next section is the bend allowance, which is where I tell SOLIDWORKS how the bend allowance is calculated. There are 5 types of bend allowance: bend table, K-factor, bend allowance, bend deduction, and bend calculation. The default setting is K-factor. I'll leave this set at 0.5 for this example. Later, we'll examine K-factor and the other bend allowance options more thoroughly. At this point, I'd like to point out an option that I skipped above. Rather than manually specifying the thickness, bend radius, and K-factor for your sheet metal, you can instead enable the option to use a sheet metal gauge table. If I check the Use Gauge Table option, you can see I have a list of tables available. These are provided by SOLIDWORKS. I'll select the aluminum table, and you can see I now have the option of selecting a gauge and bend radius as prescribed by the gauge table. The K-factor value is provided by the table as well. Notice each of these values also has an override option that allows me to replace the table-generated value with my own. For now, I'll clear the gauge table option and continue with the next set of options. The last portion of the sheet metal properties is the auto relief section. In sheet metal design, relief refers to the small cuts sometimes needed to allow sheet metal to bend appropriately. There are 3 types of relief available in SOLIDWORKS. They are rectangular, tier, and obround. Since this part does not require relief, we'll take a closer look at these options using a different example a bit later. I'll hit the green check, and you can see the completed base flange with the thickness and rounded corners added. Now that I've created a basic sheet metal part, it is time to look at some of the different options available for bend allowance. To view these options, I simply click on the sheet metal feature and choose Edit Feature. Notice in the bend allowance section, the pull-down has 5 options as discussed earlier. These are bend table, K-factor, bend allowance, bend deduction, and bend calculation. Let's take a look at each type. The bend table option allows SOLIDWORKS to calculate the bend allowance or bend deduction values from a table. The bend table takes into account the bend radius, bend angle, part thickness, and material. Bend tables can be modified using Microsoft Excel. If you're interested in creating a bend table, I suggest you copy one of the sample bend tables that SOLIDWORKS provides and adjust it to fit your needs. We'll take a more thorough look at modifying a bend table in the next lesson. The second type of bend allowance is K-factor. This is the ratio that represents the location of the neutral sheet measured from the inside with respect to the thickness of the sheet metal. You might want to look up K-factor in the SOLIDWORKS online help. If you do, you will find this helpful diagram that makes it a bit easier to understand. Next, we have bend allowance and bend deduction. These options allow you to manually type in your own parameters. Unless you're very experienced in sheet metal, my suggestion is that you stick to the first 2 options. These can lead to trouble if you don't know what you're doing. Also, we have bend calculation, which lets you define and assign equations to different angular ranges and calculate the developed length of the part. For those wishing to learn more about bend allowance and the mathematical equations behind each type, take a few minutes to review the SOLIDWORKS online help. There is plenty of information there to satisfy your curiosity. Unlike the other options available for bend allowance, the bend table option uses a table to calculate the bend allowance parameters. SOLIDWORKS will accept bend tables as either text files or Microsoft Excel spreadsheets. SOLIDWORKS has provided some sample bend tables located in the installation directory. The default location would be C, Program Files, SOLIDWORKS, then Lang, English, Sheet Metal Bend Tables. You will find several files in this folder. One of the files you'll find is called sample.btl, and it's actually a text file where the extension has been changed from .txt to .btl. All I have to do is open it in any text editor such as Notepad, and you can see that I can edit the values as needed. It is important to note that this file and all the other files in this directory are strictly sample files. Before using them on your own parts, you should make a copy of a sample file and then modify the values to suit your needs. Although SOLIDWORKS allows the use of a text file, it is highly recommended that you use Excel spreadsheets for your bend tables. They are much easier to work with, and they are embedded into the SOLIDWORKS part file, so you never have to worry about including an extra file when sending your sheet metal part to someone else. The only reason to use a text file instead of Excel is if you have an old legacy part and bend table that was created in SOLIDWORKS 2000 or earlier version. Let's take a look at one of the sample Excel files. I will double-click on one of the files located in this directory. Notice that it opens up and is basically blank. It's up to you to enter your own values. To see a completed table, you can review the spreadsheet called Bend Allowance located in the Bend Allowance directory. This file has values already filled out. You will also notice that this is for a soft copper or brass material, and in the comment cell down here at the bottom, it states it was extracted from a machinery handbook. Now that you've seen what a bend table looks like, let's take a look at how to incorporate a bend table into a sheet metal part. I will go back to my sheet metal part, and then click on the sheet metal feature and choose Edit Feature. Now I can use the pull-down in the Bend Allowance section to specify the bend table option. I click the Browse button to browse to a directory containing bend tables, which in this case is the Bend Allowance sample directory. Then, from the second pull-down menu, I choose a table, and then click the green check to accept the changes. I am now using a bend table for my default bend allowance. In this lesson, we'll be taking a look at the flat pattern feature and its options. Like any other feature, I'll click on it and select Edit Feature to access the Flat Pattern Property Manager. The first section is where you specify the fixed face. The fixed face is the face of your sheet metal part that remains stationary while the other faces bend around it. To change the fixed face, you simply select the face in the graphics window while the fixed face field is active. Let's take a look at the next section of the Flat Pattern Property Manager. It's the checkbox labeled Merge Faces. This will merge all faces that are planar and coincident in the flattened state. Let's look at the part with this option selected. I will first get out of this feature, and then click the Flatten button from the sheet metal toolbar. Notice there are no edges where the bends meet. The sheet metal part is all one face. Now I will go back into the Flat Pattern feature and uncheck the Merge Faces option, then click OK. Now, in the flattened state of this part, you can see the faces of the bends. The next option to explore is the Simplify Bends option. This option controls how curves in the bend region are treated. With Simplified Bends selected, SOLIDWORKS will make linear edges out of curves in the bend region. Let's take a look at a different part. This part has a cut that goes across the bend regions, creating a curved edge in those regions. The default is set to Simplify Bends, as you can see when I edit the Flat Pattern feature. I will unselect it and click OK. Now, when I flatten the part, the edge in this bend region is curved. I will go back into the feature and check the Simplify Bends option. Now when I look at the flattened part, the edge in the bend region is a linear edge that is easier to manufacture. Back in the Flat Pattern feature, I want to briefly mention the Show Slit option here. Sometimes when working with sheet metal, you'll need to create a corner relief with a smaller relief than bend area. In order for that bend to be possible, SOLIDWORKS will add a slit to the corner, and the checkbox here will allow that to be seen in the Flat Pattern. I'll switch back to the first part I was working on to show the next option in the Flat Pattern feature, the Corner Treatment checkbox. This controls how SOLIDWORKS displays the corners where bends meet. With this option checked, SOLIDWORKS adds corner treatment to all the corners to create a clean, flattened sheet metal part that is correct for manufacturing. If I uncheck this option and then flatten the part, you can see that the corners where the bends meet do not have corner treatment applied and do not meet correctly. I'll edit the Flat Pattern once again. In the Grain Direction box, I can select an edge or line in the graphics area to specify which direction the grain runs on the sheet metal stock. I also have the ability to exclude faces from the Flat Pattern. Let me switch to a different part to show you what this option does. Here I have a table made using sheet metal features. Notice I've created some non-sheet metal features as well near the bottom of the table legs to give the design a little extra support, making this a multi-body part. However, since these aren't bends, they could cause some problems when flattening the sheet metal part. Let's take a look at what happens. I'll switch over to the Flat Pattern, and when I do, you can see I do indeed get an error message. To fix the error, I'll click the Flat Pattern feature in the Feature Manager tree and select Edit Feature. Now notice at the bottom there is a Faces to Exclude selection box. I'll click inside the box to activate it, and now I can select each of the faces of that extrude feature that's causing the problems. Once I have all the faces selected, I'll click the green check, and you can see SOLIDWORKS can now flatten the part without any problems, since those faces are now no longer considered. And when you switch back to the bend state, you can see they come right back without the need to unsuppress anything. The next feature we'll take a look at is the Edge Flange. This can be used to add a flange along an edge or multiple edges of your sheet metal part. To add an edge flange, all you need to do is to click the Edge Flange button and then pick the edge or edges you wish to add the flange to. You can also do this in reverse. That is, you can select the edge first, then the Edge Flange icon. A preview of the flange appears, as well as the Edge Flange Property Manager. Let's take a look at the options in the Property Manager. The first area is where you define the edge and the flange profile. By default, SOLIDWORKS will make the edge flange the entire length of the edge you selected. If you wish to change this, you can click the Edit Flange Profile button. I'll make a couple of changes. I want the profile to be shorter than the entire edge, and I'll add some 1/4-inch sketch fillets to the corners. All of the sketch options are available while in Edit Flange Profile mode. Just remember to keep one edge of your sketch on the edge of the part you selected. Otherwise, you can add sketch entities, dimensions, and relations just like any other sketch. When you have the profile you want, you can either click Finish to accept the edge flange or click Back to continue adjusting the edge flange properties. Since I have not adjusted the properties of the edge flange yet, I will click the Back button. I have the option to use the default radius, the one contained in the sheet metal feature in the feature tree, or to specify a different radius by clearing this checkbox and entering a value. I can also change the angle of the flange from the default 90 degrees to another angle. The next section of the flange properties deals with the length of the flange. As you can see, you can change it from blind up to vertex, or up to edge and merge. The up to edge and merge option is used to combine two separate sheet metal bodies with the same thickness. The two bodies must also have parallel linear edges. We will look at this option in a future lesson. If you leave it on a blind flange length, it is important to note the buttons underneath the spin box. The first measures the length from the outer virtual sharp. This means the length is measured from the outside face of the part. The second button measures the flange from the inner virtual sharp, or the inside face of the part. The third button measures the tangent length of the flange. I will choose to measure 1 inch from the outer virtual sharp. The next area to look at for the definition of this edge flange is the flange position. This option controls how the material will be added to the sheet metal part. There are 5 buttons that will allow you to specify the position. Your options are material inside, material outside, bend from virtual sharp, or tangent to bend. Perhaps the best way of understanding what each of these does is to click on each of the options and notice the different results in the preview. If you wish to extend the flange, you can add an offset distance by checking the offset checkbox. As you can see in the preview, this extends the edge flange away from the part. I will use the material inside option. In order for this flange to be bent properly, SOLIDWORKS recognizes that relief cuts will be required, so it will automatically add them. You might recall from the base flange lesson that the parameters that define the shape and size of these relief cuts are found in the sheet metal feature. Here at the bottom, you have some settings you can use to override the default bend allowance and relief type. I'll use the default values and click the green check to finish this flange. Notice the relief cuts that were automatically added extend past the bend region, allowing this flange to be folded without deforming the rest of the material. Let's edit the sheet metal feature and look at the settings that control the size and appearance of these cuts. To do this, I click on the sheet metal feature and choose Edit Feature. The area I'm concerned with is the last section called Auto Relief. This is where I specify my default relief type. As you can see, it is currently set to rectangular with a ratio of 0.5. I can change this to obround or tier. With obround and rectangular relief, I can specify a relief ratio. The relief ratio is defined as the distance of the relief gap divided by the part thickness. Take a look at this diagram to help illustrate how relief ratio is defined. You can find this diagram by searching for relief ratio in the SOLIDWORKS online help. Getting back to the edge flange, there is another setting you might have seen in the Property Manager called Trim Side Bends that I didn't explain earlier. This controls how the addition of an edge flange will affect surrounding bends. Let me add another edge flange, this time letting it span the entire length of the edge. If I complete the flange without the Trim Side Bends option, you can see it does nothing to the surrounding bends. If I edit the flange and check the option to trim sides, you can see that it has trimmed the bend region of the surrounding bends. I mentioned earlier that the edge flange can be applied to multiple edges at once. This can be a big time saver, especially when adding flanges to adjacent edges like I have with this part here. I'll click the edge flange icon and select an edge. Notice as I drag the pointer that the preview of the edge flange is updating. I'll click once again to establish the length of the flange. Next, I'd like to select the 2 other edges on the end of the part. Be sure to click in the edge selection window to activate it. If you don't, selecting additional edges will do nothing. As I select the 2 additional edges, notice a preview appears for each one. For adjacent edges that would otherwise intersect, SOLIDWORKS automatically miters the corners. Before clicking OK to accept these settings, notice the arrows that appear next to each flange. They are different than the gray arrows, which allows me to change the length of the flanges. If you click on one of the arrows, the direction of the flange will be flipped. Each flange's direction can be independently controlled, unlike the gray arrow, which controls the length of all flanges. In addition to the settings you saw in the first edge flange example, here we also have control over the gap size in the Property Manager. The gap size refers to the space between the mitered flanges, as you see here. SOLIDWORKS allows you to add edge flanges to curved edges. There's just a couple of rules you have to keep in mind. The curved edge you wish to add the flange to must be on a planar face, and if you want to select multiple edges for the flange, the edges must be tangent. Let me show you what I mean. To get started, I'll click the edge flange icon. When the Property Manager appears, I'll select the curved edge and give the flange some length. At this point, I can add the edge that's tangent to the curved edge, but I can't add either of the other edges since they are not tangent. If I try to add either of them, SOLIDWORKS will prompt me that this is not possible. I would have to add flanges to these edges in a separate edge flange feature. Just like with any other edge flange, I can specify an angle for the bend and can adjust the length and direction. I can also control the flange position, such as choosing material inside, material outside, bend from virtual sharp, and tangent to bend. For this example, I'll use material outside, and you can see the result. You can also see the relief that's being added to the flange, which is the default relief type specified in the original sheet metal feature. If you do not want a relief on a bend like this, you can accomplish this by activating the Custom Relief Type section and choosing No Relief from the dropdown. I'll click OK, and the flange is complete. The part can be folded and unfolded just like any other sheet metal part. Next, let's take a look at the miter flange. I'll make a simple sheet metal plate. To do this, all I have to do is draw a rectangle and click the Base Flange tab button. You will notice that the property manager for the base flange does not give me the extrude options. This is because the profile is a single closed contour instead of an open contour like we used in the base flange lesson. Although there are no bends in the part at the moment, you can still define the sheet metal parameters. Before I go on, let's take a look at a completed miter flange on another part. You can see that the miter flange, unlike the edge flange, can have bends already added. The shape of the miter flange is defined using a sketch. The placement of this sketch is important. If I highlight the sketch, you can see that it captures the profile of the flange. Notice it is sketched on a plane that is perpendicular to the edge where we want our flange to be created. In other words, if you look directly into the sketch plane, you'll be looking right down the edge where the flange will be added. Let's go back to our new part and see how this sketch is created. I want the flange to be along this edge, so the sketch I need to create should be on a face perpendicular to that. So which face should I use? This one, the small face that is only as big as the thickness of the sheet metal. It's so small that you will have to zoom in pretty close to select it. If you want to avoid zooming in, you do have an alternative. If you click the Line tool or any other sketch tool from the sketch toolbar, SOLIDWORKS will prompt you to select a plane, face, or edge to begin your sketch. If you select the edge where you want your miter flange to go, notice SOLIDWORKS will begin a sketch for you in the proper orientation. A couple things to note about using this method. SOLIDWORKS is not actually beginning the sketch on the small face. It is creating a new plane, normal to the edge you select. This can add some clutter to your feature manager tree. You should also know that the sketch plane will be created on the side of the edge closest to where you pick. I picked closest to this end, so the plane was created here. Had I clicked closer to this end, I would be sketching on the other side. One final thought before we move on. I clicked the Line sketch tool, then selected the edge to begin my sketch. I could have also selected the miter flange icon, and SOLIDWORKS would have prompted me to select a plane, face, or edge, just as it did when I used the Line tool. Let's continue with the sketch. The profile shape can be just about anything, as long as it connects to the body of the sheet metal. If your profile will include bends, don't worry about rounding corners. SOLIDWORKS will take care of that. Once the sketch is complete, click the miter flange button, and the property manager will show the options you have when using the miter flange. First, we have a selection window. This is where you identify which edges will be affected by the miter flange. One edge is already selected based on the location of the profile sketch. If you need to extend the miter flange beyond this corner, you can continue selecting edges. The edges must connect to the first edge. That is, I can't select this edge, but if I select this edge, you can see the miter flange will continue. Since you're introducing new bends into your sheet metal part with this feature, you do have the option of changing the bend radius used by unchecking this box and specifying a different value. If you leave the box checked, the part's default bend radius, the one defined in the sheet metal feature, will be used instead. Next, you have the flange position option. As we saw in the edge flange lesson, this will control how the flange material is added to this part. Notice that if I use the material inside option, the overall length and width of this part will remain the same as the original plate I started with. This is important if you've sized your plate to fit within a tight tolerance. If you use either the material outside or bend outside options, the overall size of the part will be larger than the original plate. Keep this in mind so you're not surprised later if your part is larger than you expected. The Trim Side Bends option is available here just as it is when you created an edge flange. The next option is the gap distance. Another useful feature for designing in the sheet metal environment is the swept flange. It's pretty similar to the miter flange, and as you might expect, it behaves similarly to the regular sweep feature found on the Features tab. We've already seen how to add edge flanges around curved edges as long as they were tangent, and how to use the miter flange tool to create compound bends. The swept flange tool lets you quickly accomplish both of these at once. Here I have a blank part. Just like the sweep feature, the swept flange requires both a profile and a path in order for it to be created. I'll create two sketches here to serve as the profile and path, but just so you know, you can also use model edges for the path, just as you can with the regular solid sweep. I'll start a new sketch on the front plane and use the Line tool to create a simple sketch. Here's something important to remember, and a big difference between the solid sweep and the swept flange. Unlike the solid sweep, the profile sketch for a swept flange must be an open contour. If you don't leave the sketch open and close it instead, the swept flange will fail. This series of lines is pretty obviously an open contour, so I'll exit the sketch to finish the profile. For the path, I'll start a second sketch on the top plane. The path can be either an open or closed contour, straight or conical, or like I mentioned earlier, model edges. But like all designs in SOLIDWORKS, you have to pay attention to the manufacturability of your parts. Using a closed contour such as this for the path means the part could end up being nearly impossible to manufacture. So to fix this, for our example here, I'll delete a few line segments before exiting the sketch. The swept flange doesn't appear by default on the sheet metal toolbar. To add it to the toolbar, I can go to Customize and switch over to the Commands tab. In the sheet metal category, I'll look for the swept flange icon and drag it onto the sheet metal toolbar. Alternatively, you can also launch the command from the Insert, Sheet Metal drop-down menu, or you can simply search for the command in the search bar. When the Property Manager appears, notice the message window prompts me to first select an open sketch for the profile, and then select a sketch or series of existing sheet metal edges as the path. I'll select the first sketch as the profile, and the curved sketch as the path. When I do, a preview appears, and the Property Manager updates. When the Flatten Along Path checkbox is selected, the profile is flattened and rotated parallel to the path plane, which results in a flat pattern similar to the path shape. Cylindrical conical bodies lets you specify a reference line to correctly flatten the part. With the option enabled, you can select a sketch entity and the flattened part is conical. I'll leave these options cleared for now. Below these options, you can specify the sheet metal parameters, bend allowance, and auto relief, as well as use a gauge table. I'll leave them at their defaults, click the green check, and the swept flange is created. Also notice that since this is a sheet metal feature, the flange was given thickness defined by the sheet metal part, which is why we didn't use a closed contour for the profile shape. Notice how quickly I was able to create pretty complex compound bends, and all in a single feature. But be careful not to get carried away here. Just like with the regular sweep feature, if your geometry ever self-intersects, even if it doesn't appear obvious at first, for instance when sweeping a complex profile around a tight bend, SOLIDWORKS won't be able to calculate the geometry. Before wrapping up, notice when I flatten the part, the result is a rectangular sheet, which doesn't correctly represent the shape I specified. If you would like more control over the flat pattern shape, use the Flatten Along Path or Cylindrical Conical Bodies options. I'll edit the feature and check the Flatten Along Path checkbox. When this checkbox is active, notice I can also select Material Inside. Depending on the geometry, SOLIDWORKS may only be able to generate a flat pattern if this option is either checked or cleared. I'll leave Material Inside cleared and click OK. Now, when I flatten the part, you'll see the geometry updates. I'll close the flat pattern and edit the feature once again. This time I'll select Cylindrical Conical Bodies. Notice the Flatten Along Path option was automatically cleared and a selection box appeared. This selection box requires a linear sketch segment that is part of the profile to be used as a fixed entity when the part is flattened. I'll select the lower segment of the profile and click OK. Now, looking at the flat pattern of the part, you can see that the segment I chose as a fixed entity was referenced, and the flat pattern more accurately represents the conical shape. As you can see, SOLIDWORKS can calculate a flat pattern for swept flanges in a variety of ways, but it might not always look the way you expect it to. You'll definitely want to double check and make sure there are no errors when you flatten the part. And as I mentioned earlier, you'll want to verify whether or not the part you modeled can actually be manufactured. If you need to create a cut across a bend, there is a specific process you must follow. It involves using the Unfold and Fold features. One thing many new users will do is simply flatten a part using the Flatten icon on the sheet metal toolbar and then create cuts across bends. I want to take a moment to show you why this is the wrong approach. I'll click the Flatten button from the sheet metal toolbar and create an extruded cut across one of the bends. When the cut is complete, notice that the Cut Extrude feature is located below the Flat Pattern feature in the Feature Manager tree. When I click the Flatten button, you can see that the Cut Extrude is suppressed. This is because any feature you add in the flattened state becomes a child of the Flat Pattern feature. This is why it is important not to work on your sheet metal part in the flattened state. The proper way to add a cut across a bend is to first unfold the bend using the Unfold feature. To do this, click on the Unfold button from the sheet metal toolbar. As you can see in the Property Manager, all you need to do is pick a face to remain fixed, and then pick a bend, or multiple bends, to unfold. If you want to unfold the entire part, use the Collect All Bends button to quickly select every bend. To select a bend, all I have to do is click on the bend region, and it will be added to the list. When the bends are selected, click OK, and the bends will unfold. Now I can open up a sketch and create an extruded cut across a bend. I will sketch a circle and choose the option to link to thickness in the Cut Extrude properties. Once the cut is complete, I will use the Fold feature to refold the flattened bends. I'll click the Fold button from the sheet metal toolbar to activate the command. Notice the fixed face is already selected. This comes from the Unfold command. All I have to do now is select the bends to refold, or click the Collect All Bends button to add the bends to the list. With the bend selected, I'll click the green check. You can see that the cut appears above the flat pattern feature in the Feature Manager tree, and it wraps around the bend as you would expect.